Hi everyone, we're going to solve absolute value equations. Don't forget the definition of the absolute value equation is here. So you have to use this, you have to use x if x is positive and negative if x is negative. So in this case we have 7. I plug in the 7 here and that just equals x, so we just put 7. However, we have negative x here, so negative times a negative x equals positive 7. Right, in this case, absolute value of 0 is 0. Absolute value of negative 1 is 1. 0 plus 1 equals 1. This is like taking care of what's in the parentheses. We're going to get the absolute value of 1, and that equals 1. It's kind of like PEMDAS. Here, take care of what's in the parentheses. We're going to get 10. This equals plus. So 10 plus 7 is 17. That equals 17. All right, now we're going to get a little harder and harder. That was basics. Okay, let's go over a couple more basics here about domain and range. When they give you the domain like this, they're just talking about a table of values. So they're saying if x is negative 1, this is a set. So these 2 points belong to the set. And if 5, so if we plug in negative 1 here, we get 3 times negative 1 minus 17. That's going to give us the absolute value of negative 3 minus 17, which equals the absolute value of negative 20, which equals 20. So when x is negative 1, our y is 20. So that goes there, comma. And now let's look at this one. We have 3 members of our set. We have negative 7, 5, and 0. So we're just going to evaluate and plug this in. We're going to plug in, oh, we forgot to do 5. So let's plug in 5 here. So let me do that in a different color. I'm back up here. Sorry, guys. All right, so we're going to do the absolute value of negative 3 times, or it's positive 3, times 5 minus 17, absolute value. That gives us absolute value of negative 2, which equals 2. So we put the 2 here. Let me put it back in green. 2 goes here. Now let's go back to the number 2. Our domain is negative 7, 5, and 0. That's the members of the domain set. So we have to plug all these in. When I plug in negative 7 here, I get absolute value of 14, which equals 14. This is absolute value of negative x plus 7. This is my f of x. And so that's going to equal 14. And now let's do the 5. Negative 5 plus 7. That equals absolute value of 2, which is just 2. And we're going to plug in 0. And we get 0 plus 7. These are 7s. Which equals absolute value of 7, which is just 7. So that's some of the basics. And now we're going to get on to solving. Okay, the first one we're going to solve is absolute value equals 5. And I do this a little different. I'm going to make a table on all of these. And I'm going to solve on both sides. So when you do this, you can write x equals 5 on this side and x equals negative 5 on this side. All right, so basically, if you plug in and then we do, basically we don't have to solve because it's right there staring us in the face. So basically, if you plug in and check, does absolute value of 5, does that equal 5? Yes. And now plug in negative 5. Does that equal 5? Yes. So these are our 2 solutions. And you really don't want to write them like this. You want to write them as a solution set, as members of the solution set. So we have 5, negative 5. And that's as a set, not an ordered pair, as a set. Okay, this one's a little more, well, this one's not that bad either. Since we have 0, we don't have to do the table. We can just take off the absolute value signs and solve for x. So we get 3x equals 7. I remember that this is algebra 2. So we're going to add 7 to both sides. So we get 3x equals 7. Then we're going to divide both sides by 3. So we get x equals 7/3. Again, we don't want to leave it like that, but let's check and make sure we did this right. So I'm going to plug in my x and make sure we did this right. Is this true? So 3, I can write 3 in fraction form. The 3's would cancel out here. So we're going to get 7 minus 7, absolute value. Does that equal 0? Yes, 0 equals 0, so it checks. And our solution set is 7/3. The next one we have is absolute value of x plus 6 divided by 3 equals 4. And what I'm going to do here is cross multiply and get this absolute value quantity or argument, if you will, separated out. So I'm going to cross multiply 1 times absolute value of x plus 6 is just the absolute value of x plus 6. I tend to cross up like that. All right, and then 3 times 4 is 12. All right, now what I'm going to do is make my table. And when you make your table, you're going to show the positive and negative. So we're going to do absolute value. Oh, we can take off the absolute. Let me rewrite this real quick. So basically our equation is absolute value of x plus 6 equals 12. All right. Now from here, I'm going to break this down into 2 pieces. I'm going to just copy it down without the absolute value signs. On this side, I'm going to write x plus 6 equals negative 12. So you negate this side over here. Now let's solve for x. So you're going to add 6 to both sides, and you get x equals 18. Here you're going to subtract 6 from both sides, and you get x equals negative 18. Now we need to check this, and I'm going to plug it back in. I'm not going to plug it in to this equation. I'm going to plug it in to this equation, because what if I made a mistake when simplifying? And I do make lots of mistakes, so I'm going to plug it in and just check it out. So I'm going to see if I did it right. So it's 18. Oh, here I did make a mistake. See? It's a good thing you check. So here we should have done what? We should have subtracted 6. So subtracting 6, and you all probably saw that really fast. So too bad I can't hear you. X equals 6. So did I do the other side right? Yes. Okay, so let's check. I'm going to plug in these 2 values and see if it works. So here's the first one I'm going to do. So does 6, absolute value of 6 plus 6, does that equal 12? Yes, because absolute value, this is 12, and 12 equals 12. All right, now let's do the negative 18. So do the negative 18 over here. Is the absolute value of negative 18 plus 6, does that equal 12? Well, we get absolute value of negative 12. Does that equal 12? Yes, because absolute value of negative 12 is 12, and 12 equals 12, and that checks. So our solution set is these 2, 6, negative 18, curly brackets. All right, there's your solution set. Now, this one, we want to get it in the form so we can do our little table. So what I'm going to do is add 12 to both sides. And then I get 3 times absolute value of x plus 8 equals 12. Then I'm going to divide both sides by 3. So I get the absolute value of x plus 8 equals 4. And I just realized on the other page, I checked with this, I didn't check with that. But if you check, you'll get that. Anyway, now we make our little table. So we have the absolute value of x plus 8 equals 4. And I'll make my little chart here. I'm going to just copy it down. X plus 8 equals 4. And then on this side, I'm going to write x plus 8 equals negative 4. I solve for x here by subtracting 8. And that's going to give me x equals negative 4. Here I subtract 8 from this side, both sides, and I get x equals negative 12. Now, hopefully I did that right. Now, let's do it the right way and plug it back in the original equation, not the one I adjusted. Because, again, I could have made a mistake here in this area. I probably didn't, but so let's plug it in. We're going to have 3 times negative 4 plus 8, absolute value of negative 4 plus 8 minus 12. Does that equal 0? And here what we're going to do is take care of this quantity or this argument here. Sometimes you could call this the argument. I'm going to call it that. So we have 3 times absolute value of 4 minus 12. Does that equal 0? Well, absolute value of 4 is just 4. So does 3 times 4 minus 12, does that equal 0? And yes, because this equals 12. So 12 minus 12 is 0. Now let's try negative 12. And let's see, I'll use green. So we're going to have 3 times the absolute value of negative 12 plus 8 minus 12. Does that equal 0? So that's 3 times absolute value of negative 4 minus 12. Does that equal 0? Well, the absolute value of negative 4 is 4, so that's just 3 times 4 minus 12, which is 12 minus 12, which does equal 0. So that checks. So my solution set is negative 4, comma, negative 12. Okay. Here's another one. I'm going to first add 12 to both sides. It's like when you're solving, you do PEMDAS backwards. First you add and subtract, and then you see if you can multiply or divide. And when you do 12 to both sides, we're going to get 2 times absolute value of 2x minus 5 equals 16. Then I'm going to divide both sides by 2, and I get the absolute value of 2x minus 5 equals 8. Now I can do my table here. And to save room, I'm just going to write it here. This is 2x minus 5. Let me move it over a little. 2x minus 5 equals 8. And what do we write on this side? 2x minus 5 equals negative 8. Solve for 8 by adding 5 to both sides. You get 2x equals 13. And this side's going to be, if you add 5 to both sides, you get 2x equals negative 3. So x equals 13 over 2. We're dividing both sides by 2. And x equals negative 3/2. We're dividing both sides by 2. I just did it mentally. All right, now we have to check this. All right, so let's check this one. We have 2 times 2, absolute value of 2 times 13 over 2 minus 5 minus 12 equals 4. Does that equal 4? Equal 4. This right here is 13, so we have 2. These 2 cancel. We get 13 minus 5. Minus 12. Does that equal 4? 13 minus 5 is 8, so we have 2 times the absolute value of 8. Minus 12, does that equal 4? And so absolute value of 8 is 8, so we get 2 times 8 is 16. Minus 12 does equal 4. And you can finish writing there. Now let's try the other side. We have 2 times the absolute value of 2 times negative 3 halves, minus 5, minus 12, this absolute value. Let me scoot it over. Why do I do this? All right, I'll write smaller. 2 times the absolute value of 2 times negative 3 halves, minus 5, and then minus 12. Does that equal 4? So I'm going to simplify that here. Hopefully you are going at negative 3 minus 5 minus 12. Hopefully you are writing this down. Now, this quantity inside here is negative 8, so we get 2 times the absolute value of negative 8 minus 12. Does that equal 4? Absolute value of 2 is 8, so 2 times 8 minus 12 equals 4, or 16 minus 12 equals 4. So therefore, our solution set is this. It's 13. So I'm glad we got it right. 13 over 2 and negative 3 over 2 is our solution set. All right. Okay, here's one. I'm going to let you do the checking because the video is kind of running a little long. So basically, everything's already set up. And what we're going to do is just do our table. I'll do our table in the middle here. So we're going to write this as negative 3x plus 7 equals negative x plus 5. I'm going to write this up. Plus 5. And this side's going to be negative 3x plus 7 equals negative x plus 5. So we're just taking the negative of this side. And I'll let you do the checking. So we're going to solve for x. I'm going to do 2 steps at once. I'm going to add 3x to both sides. I'm also going to subtract 5 from both sides, just to save room. So this will cancel, and you get 2 equals, this is going to be 2x, and this part cancels. So x equals 1. This side's going to be negative 3x plus 7 equals x plus 5. And I'm going to add 3x again to both sides. And I'm going to subtract 5 from both sides. 2 steps at once. Here this cancels, and then all you have to do is add. And we're going to get 2 equals 4x. So x, you divide both sides by 4. I want to do this in my head, so forgive me if I'm trying to skip steps. Okay, so x equals 1/2, because that cancels, and 2/4 reduces to 1/2. So your solution set is 1, 1/2. It doesn't matter what order. Again, you could write this as 1/2, 1. And you need to check. So plug those 2 values in each x, and like we did on the previous videos, and it should work. And we'll do one more quickly. Okay, maybe I'll do this one a little neater. 4x minus 9, just copy it down, take away the absolute value sign, and then you're going to take it away again, but on this right-hand side, you're going to say negative times negative 6x plus 1. And then you solve for x. And I'm going to add 6x here, and I'm going to add 9 here. So I'm trying to get x on one side. So this x cancels on this side, and the 9's cancel here. And I get 10x equals 10, so x equals 1. And this side, I'm going to get 4x minus 9 equals 6x minus 1. I'm distributing, I'm negating this, or I'm distributing negative 1. I'm going to subtract 4x. I like my x positive. And then I'm going to add 1, excuse me, to both sides. This cancels, and then we're going to get negative 8 equals 2x. So x equals negative 4. I just divided both sides by 2 here. And your solution set's going to be 1, negative 4. And again, just plug it in and check your solutions. And that is all. The next thing we're going to do is graph solutions on a number line. Okay? And then we're also going to try to solve inequalities.